Welcome to Vipin Sharma Physics channel. Dear students, I am going to discuss a very interesting concept with you. The concept is from the chapter Properties of Bulk Matter, and it's basically a query asked to me by a student. So what is the query? Let me tell you. Dear students, you see a boat full of stones and it's in a lake. It is in a lake water, right? It's in where? It's in the lake water. You all know that lake water is a still water, or you can say it's a pond. All right. Now, the level of the lake is of height h. Right? Now what we do is we unload the stones one by one, and the boat is made empty, but we have thrown those stones in the still lake water. You got my point? I will be uploading this lecture in two versions. One is in English and the other is in Hindi or Hinglish. So it is first in English. I repeat the question. There is a boat having stones in lake water or a pond water. We unloaded the stones and dropped one by one into the lake water. Correct? Before we unloaded the stones, and that is before we dropped the stones one by one into the lake water, the level of the lake water was h, and after that it is h dash. Now the question starts, is h greater than h dash? Is h less than h dash? Is h is equal to h dash? D cannot say. The three are very authentic. H is greater than h dash, h is less than h dash, h is equal to h dash, cannot say. Now, the statement is clear. I just leave aside and you try, take a screenshot and try. Now, students, you must have come to certain conclusion. I am coming to my answer. See, we will not talk about all these stones. We will just take one stone. Okay, the stone is, say, a cube size. For the sake of convenience, we take the stone as a cube. So it is 5 centimeter, 5 centimeter, 5 centimeter. Then volume of stone actual is 125 centimeter cube. And suppose this stone 125 centimeter cube is weighs 1 kilogram. When 1 kilogram is floating in the boat, when 1 kilogram is floating in the boat, so what happens, dear students, it will displace volume of the water VL and the density of the pond water, lake water, is sigma into G, correct? And the volume of the stone is not 125 cc because it is floating. So volume displaced by the stone to stop the float, so upthrust is VL sigma G. VL sigma G must be equal to what? Volume of the stone displacing the liquid, and that is into GVS rho Z. Rho is the density of the stone. G. Hope it is clear. Simple it is. Now, dear students, G gets cancelled. VL sigma equal to VS rho. Hope it is crystal clear to you. VL sigma is equal to VS rho. Now, dear students, VL upon VS equal to rho upon sigma. Correct? Rho is the density of the stone. Sigma is the density of the liquid. See, VL is greater than VS because rho is greater than sigma. Density of stone is greater than water, therefore VL is greater than VS. Now, when 1 kilogram stone is floating, the volume of the liquid displaced is more than the volume of the stone. When you drop the stone, then volume of the liquid displaced V dash L must be equal to the volume of the stone, which is equal to 125 centimeter cube. It means that when you drop stone one by one into the still pond water or lake, the volume displaced for one stone is 125 cc when it is totally sink and settled at the bottom. But when it is floating, the volume displaced is VL, which is greater than actual volume of the stone. Consequently, when the stones are floating, volume displaced is more. But when the stones are dropped one by one, volume displaced is less. Conclusion: the level of the pond will go down. Okay, so this implies H dash is less than H, or this implies H is greater than H dash. So this is the right explanation to this question. Your comments are welcome. And conclusion, when you are dropping the stone into the still pond of water, the level will fall. When you are having all the stones in the boat, it will displace more volume to make those stones to float, because it requires more upthrust. The level of the liquid will rise. Your comments are welcome. Thank you very much.